Hello everyone. Uh, Welcome to my very first video of the new series I'm going to create about data structures and algorithms. Uh, and I plan to explain each and every algorithm from easy to medium to hard, one by one, starting from easy ones. So, and the main purpose of the creating this playlist would be to give an idea as to how easy uh, we can make the logic of algorithms if we understand them thoroughly. So I'll be going through the easier data structures first, starting with arrays, and some after we build some logic building about that, then we can move on to the other complex data structures, such as linked list and queues and stacks and hash maps and graphs. So one by one we'll understand. So the the today's video I'm going to talk about the data structure arrays, and especially a searching algorithm called the linear search. The Now, linear search. When we talk about searching in arrays, let's say we have an array called 1, 3, 7, 15, 30, and let's say 50. Uh, let's not mind that this one is sorted, because linear search does not care if the array is sorted or not, because if it is sorted, and we obviously wouldn't be using the linear search, we will be using the binary search. So let's say we want to find the element 15. So our target element, the target is 15. Now, what the linear search says, that it traverses the array one time from the zeroth index. This is the zeroth, this is the first index, the second, third, fourth, fifth, sixth, seventh. There are 7 indexes and total 8 elements, because the index starts from 0. So what the linear search says, that it traverses from 0th index to first index to nth index, which is basically our last index. So when we say it traverses from the first index, we also will put a search condition, that if our target is found in the uh, ith position, which is the 0th position in the first iteration. When it finds that if it is not in the first, so there are, let's say, there are three cases. Our There are two cases basically. If our target is going to be equal to the ith position in the array, and the second one, if it is not equal to the target position in the array, is not equal to ith position. So uh, every time it traverses the array, every time it traverses one element one by one, it will check whether the target is equal to the position in that array. So let's say we do a dry run. uh, in the first run, in the first iteration, basically it will iterate only one time, but I mean in the first case, where the element is 1 in the 0th position and our target is 15. So 1 is not equals to 15. So this case is triggered. So it will move on to the first position, which is 3 in this case. Now it will again check if the target is equal to the first element, first index, which is 3, and it is not the case. So it will again move on to the second index, which is 7. Again no. Then comes the fourth index, fourth index in the array, which is 15. Now 15 is equal to the target which we provided. Now the target is 15, and we are also in the fourth comparison, which is 15. Now here is where the first case gets triggered, which is that the target is the ith element in the array. It doesn't matter which element we are in. what matters is that the target is matched. That's why uh, the condition gets triggered and the loop gets broken, means we are exited from the loop. Now, so basically it's a linear search. That's why it's called a linear search, where every element gets checked with the target element. Let's say in this case the 15 is present in the array. Now what if our target is let's say um, equals 2. Now if 2 is not even in the array which we are going to provide, then it will traverse the entire array. It will traverse the entire array, and since 2 is not in the array, the target is not in the array, then it will traverse the entire array and will return and will return a value which we are going to provide as -1 in this case. It's a common DSA logic that when something is not present in the array, then simply provide -1. Although in arrays we usually mean that -1 is the last index in the array when we want to traverse it from the backwards. But in this case we can say that the -1 can be returned if the target is not provided in the array. So in the case of 2, which is not present in the array, it will provide -1 as the return case. So let's talk about complexity of linear search. The complexity of time and space is the space is a constant. We can say constant because there is no other arrays or no other extra space being utilized in this case for the case of space. Now let's talk about the time one. In case of time complexity, let's talk about two cases. The best case. When is the best case? The best case is when the target element is the first element, which is the 0th. In that case, it will only check the first element and will exit the loop because the target is compact and we got our target which is matching the first element of the index, and hence it exits the loop. Now this is the fastest case in linear search and is also a good one. Although no one gets usually that case, but the best and worst case should be discussed in that way. The worst case. The worst case is when the target element is either the last element of the array or not at all present in the array. So last element or not found in the array. In these two cases, we will have to traverse the entire array, which could comprise n elements. So we can say that the array is entirely traversed one time for checking if the last element is either the target or there is no or the last element is not the target, which in this case not found, and -1 is returned. So when we say we are returning -1, it basically means that we searched the entire array and we didn't find the target inside the array. So here big O of n notation when we talk about time complexity. The worst case scenario where we say that the entire array is traversed and we either got the target matching as the last element or we didn't get the target element matching in the array at all, which means that the target element was not found in the array. So it basically means that the entire array is traversed at least one time to conclude this statement. So this basically means that linear search has the time complexity of big O of n. When we talk about other data structures where there could be big O of n square, when there is a loop within a loop, loop inside a loop, we will come across those cases as well. But to be honest, the big O of n is a constant one where the worst case is entire array being traversed. So that is basically the concept of linear search. It's not a very advanced concept when we talk about searches. There are multiple other searches as well. For example, binary search and other cases where we need to use where the time complexity is even halved, where logarithmic time complexity is found. So we will come across those cases as well. But it's a good thing to know that the base search, that we can say that for the binary search, the brute force brute force scenario is linear search. The linear search, when we don't know what to find, or when we don't know where to find or how to put the logic of applying optimizing the search, we can always use the brute force, means the search every element in the array for the worst case, which is the linear search. So yeah, that's the basic understanding of the linear search. Thank you.